video is video number 6 on stimulants for the Drugs and Medicine unit in IB Chem 2. And again, a lot of what you see in this video you might have learned in another class, especially a health class. But again, it's the chemistry we want you to focus on. So what is a stimulant? Well, a stimulant is any drug that increases the activity of the sympathetic nervous system and produces a sense of euphoria or awakeness. A lot of times they're abused to boost endurance. This is where you've heard of maybe those stories of kids who are stealing other students' Ritalin or Ativan, I believe is the other drug, where it's like an ADHD medication and they take it and abuse it to keep their grades up to stay awake. And an additional side effect is that it suppresses appetite. Now, examples of some common stimulants, some illegal, some legal: caffeine, nicotine. Okay, both. Caffeine is legal. It's found in many beverages like coffee and soda. Nicotine is legal if you're 18 years or older. Amphetamines, illegal. Cocaine, illegal. And then Ritalin is by prescription only. And we'll describe that paradoxical effect in just a little bit. So stimulant abuse can eventually impair mental function and actually lead to psychotic symptoms, and that does not usually get repaired. So if you abuse stimulants to the point of a psychotic episode, chances are you're never going to get that same normal brain function back. Now, an amphetamine and adrenaline, these are related chemical structures. You can find them in data table 20 in your IB data booklet. Both are derived from phenylethylamine, or sometimes it's just abbreviated phenethylamine. And what they do is they mimic the effects of adrenaline. So they're called sympathomimetic drugs. That's not that easy to say. Now, speed, which is speed methamphetamine, has a much more pronounced physiological effect than normal amphetamines. So here are the uses. So the first thing that they do is constrict the arteries, increase your sweat production, and it's basically the same effect that you would get from adrenaline. Now remember, adrenaline triggers the fight or flight response. So when you get into a situation where you feel nervous or threatened, your adrenaline releases in your body and it releases that same kind of reaction. Strong stimulants will act on the central nervous system, and medicinal or medical uses are treatment of mild depression, narcolepsy, and asthma. Now, the problem with amphetamines is that it's kind of, think of like the last time you, well, and you probably haven't been in a situation, I hope, where you've been truly frightened, but when your adrenaline kicks in and overruns for a little while, it gives you that burst of speed, that fight or flight mechanism, but afterwards you experience this down, like you're just exhausted. And the same thing will happen by using one of these drugs. You just get exhausted after you've used one. So here's the examples of these structures. So phenylethylamine or phenethylamine is just a benzene with an ethyl group. So here's carbon number 1, here's carbon number 2, and then an amine. So benzene, the ethyl group, amine. And then you have the other drugs. So adrenaline is sort of like this. You have the ethyl group with the amine, but instead of being NH2, you have a CH3, and then you also have this OH group with these other OH groups off of this. Amphetamine looks very similar. Okay, over here, you have almost an identical side chain, an ethyl amine with a methyl group, but no OHs. And then methamphetamine, okay, so again, amphetamine with a methyl group. So here's your 1-2 carbon chain, ethyl amine, and you have this methamphetamine. Okay, so there's these methyl groups. That's why they're called methamphetamine. Now, nicotine is a common stimulant, and you've probably talked about this quite a bit in health class, so I hope I don't go through this too quickly for you, but my guess is you already know a lot of this stuff. So tobacco is a natural source of nicotine, which is a mild stimulant. When you use nicotine, you have this initial response of a stimulating effect, but then it's followed by a little bit of a depression, which encourages frequent use so that you can keep the high of the stimulant. Now, smoking causes, using tobacco, smoking itself causes all of these things that you're probably already familiar with. And I would throw in that chewing tobacco can add to the same problems. Maybe not as many, the air pollution and the bronchitis, but you can still get some of the same cancers, including of the mouth and jaw. Now, what are effects of nicotine use? So short-term effects of nicotine use, your heart rate and blood pressures will increase, your blood vessels will constrict, you have that mild stimulating effect, so you might feel more awake, more alert, and it reduces the urine output. And then long-term effects is that eventually, if you use this, you know, over several years, decades, whatever, you're at an increased risk of heart disease, coronary thrombosis, which are blood clots, can cause peptic ulcers because your body will start to produce more acid when you use nicotine, and it is obviously addictive. Now, caffeine is another stimulant. It's considered a respiratory stimulant. So there's the structure there. And if you have large amounts, it can cause anxiety, irritability, and sleeplessness. So that's why, you know, people drink a lot of coffee in the morning to keep awake. It is a weak diuretic, so it can possibly increase your urine output. And the big thing that IB wants you to understand is both caffeine and nicotine have similar chemical structures. They both contain a tertiary amine group. So if we go back to this nicotine structure back here, the tertiary amine group is this right here. Keep in mind this nitrogen is attached to 1, 2, 3 different carbons. That makes it a tertiary amine. And then on the caffeine, you have the same thing. You have tertiary amine groups here, here, and here. And that will be the end of our stimulant video. So if you have questions, we can discuss this more in class the next time we see each other.